Hello, my name is Mohammed Khan. Welcome. This project focuses on the creation of mechanical cyborg arm, modeled, textured, and rigged for both organic and mechanical movement. To begin, I used Substance Modeler in VR to create the base human mesh. This served as a foundation of the cyborg arm, providing correct proportions and anatomical reference. The first setup was detailed and blocking out the arms. At this stage, I focused on the overall silhouette and shape. I kept the mechanical elements rough to focus on the form and how the arms would connect with the rest of the body. Next, I moved to the head and chest areas where I defined the shape and volume, keeping in mind where mechanical elements like the helmet and chest plating would integrate with the rest of the body. After refining the torso and arms, I expanded the full body model. This iteration emphasized better proportions, sharper design details, and functionality. The body was adjusted to accommodate the mechanical arm, ensuring the articulation would flow naturally into the design. At this stage, I refined the connection between the head, chest, and forearm. I ensured that the mechanical components integrated logically and functionally. This was key in defining the articulation points such as the elbow and shoulder joints. I then turned my attention to the legs, ensuring they were consistent with the mechanical theme. The design was simplified to maintain focus on the arm's complexity, but still integrated similar mechanical elements like joint articulation. And here are the final renders inside Substance Modeler of the body from multiple angles: front, back, left, and three-quarter views. These renders helped evaluate the overall design and ensure everything was in proportion and ready for the next stages of my project. I also did a test render inside 3ds Max to check how lighting and materials were interacting with the model. This helped spot any issues in the geometry and allow me to fix them before progressing. This was very important for UV unwrapping. I used multiple UV tiles to ensure high detail across the mechanical surfaces. I carefully laid out the UVs to ensure that texture maps would apply correctly, focusing on areas with intricate details like the joints and armor. Here is the textured render where I applied materials to the model. I focused on realistic metallic finishes and proper mechanical details. The textures give the model a functional look, showcasing its realistic appearance as a cyborg. After this, I retopologized the arm to prepare it for rigging. I focused on creating clean edge loops around the joints to ensure smooth deformations. This was a bit difficult for the hand itself, so I then created a low poly version of the hand, which was essential for rigging and animation. It allowed for more efficient deformations and a lighter workload during the rigging process. Here's a turntable view of the low poly hand model. This showcases clean geometry and how low poly structure works for animation. Following the low poly hand, I created a high poly version to capture more detail. The high poly model was necessary for making normal maps and other texture details that would be applied to the low poly version. Here's a turntable of the high poly hand. After this, I had performed a skinning test to ensure organic hand movement. The skinning process involved weight painting to make sure the hand would actually move fluidly when rigged and animated, especially around the joints and digits. I then tested the hydraulic rigging. This part of the project focused on adding mechanical elements like pistons and hydraulics, which needed to function in tandem with the organic movement of the hand. Here I implemented a script controller to calculate hydraulic movement using a formula. To control the elbow and forearm, I used a gear mechanism. The gear-driven system allowed for smoother transitions between movements. I also set up the rig and bones for the arm and hand. Additionally, I attached hydraulics and hoses to the bones to simulate real-world mechanical movements. Here's a movement test of the arm. You can see how the rig and hydraulic systems work in unison, providing both organic and mechanical movement to the hand and forearm. This slide shows the topology of the forearm's armor plating. In this test, you can see how the forearm is controlled by the elbow rig. The elbow is key control point driving the motion of the forearm and the hand. This setup ensures that all parts of the arm move in a cohesive and functional way. Finally, the hand is linked to the forearm and the elbow rig controls both, delivering a realistic and functional arm. Thank you.